Hello everyone, welcome to this video on KNN and decision trees. In this video I will be talking about what KNN is, how it works, the performance of KNN model, and the result of KNN. I'm using the flags data from UCI repository, and I will be using that to predict the religions of the countries. But before that, I will be talking about what KNN is and how it works. K-nearest neighbor is used for both classification and regression problems. In my dataset, I have used it for classification problem because I wanted to find out the religions of the countries. In KNN classification, an object is classified by a majority vote of its neighbors. So if you have k equal to 1, and then the object is simply assigned to that class of that single nearest neighbor. In my dataset, I have set k equal to 4 because that have produced the best result among other numbers. So this is the code written so far for KNN model. First of all, we need to set the path of the file by using the setwd function and then pasting the path of your file in brackets. To store the starting time of the model, we can type system.time and then storing this time in A, or you can choose any letter or word to store your starting time in. The next step is to import the file into RStudio. We can use a read.csv function to import the file. The structure of the file can be seen using str function, and the summary of the file can be seen using summary function. The next step is to look for the target variable that we want to predict. In this case is the religion variable that we want to predict. I want to give this variable some values because currently it stores 1 for Christianity and 2 for Islam. So I will be giving 1 the value of Christianity and 2 the value of Islam to better read the program. The next step in KNN was to normalize the data. I have done this by using this formula, which normalizes the data that takes the minimum x value of your data and divides it by the maximum value minus minimum value. To see if the normalization works, we can type the new data name, which is here, and then one of the variable in the data. The next step in KNN model is to divide the data into test and train data frames. In this case, we have 26 observation of test data and 70 observation of train data. We can also create some labels for our data, and then we can predict the data using KNN function. To do that, we need to install the class library. We can do that by typing install.packages and then inside the bracket within the apostrophes type class. And then the KNN model, the KNN function would take the train data, the test data, and some labels, and it would also allow you to give k the values. In this case is 4. K equals 4 have produced the best result for my model. To see the result of the model, we can use cross table. To use cross table, we have to install Gmodel libraries. We can install this the same way we have installed the class library, and then once you have your model produced, we can see all sorts of performance measurements like the accuracy rate, the error rate, the precision of the model, and the recall. We can also see the F-score of the model. We can also produce or draw the ROC curve, but we need to install a library for that, which is ROCR library. Again, we can install this the same way as we have installed the other two libraries. Once you have installed the libraries, you can call the library by just typing library and inside the bracket the library name. And lastly, we want to find out how much how much memory the program uses by installing another library, which is PRYR, and then using this function to find out the memory used by the model. As mentioned earlier, our starting time of the model was stored in A, so we need to store the ending time of the model, which would be in B. So B minus A will give us the total time it took for the model to load. And at the end, we can just write the result of the model using write.csv function, and then give the result its name. So this is the result of KNN model. It shows that we have 23 observation correctly classified and 3 observation misclassified. So 23 out of 26 observation are classified correctly, and 3 out of 26 observation are classified are misclassified, sorry. So the accuracy for this model is 0.88, and the error rate is 0.11. So 0.88 is about 88%. So the accuracy of the model is 88%, and the error rate for the model is 11%. And the time it took to load this model was 0.53 seconds, and the memory used by the model was 28.5 megabytes. Finally, this is the result of decision trees using the same data as used in KNN model. So we have 23 observations that are classified correctly, and 3 observations that are misclassified. So the accuracy rate for this model is 0.88, and the error rate is 0.11, which is the same as KNN. So it make it the model is about 88% accurate, and the error rate for it is 11%. The time this system took to load was 0.25 seconds, and it used 28.5 megabytes of memory. So this concludes the video. Thank you very much for watching.